We are back on the rack, so let's go ahead and get our ACLs written. Done and done. Let's go over to router 3. And those ACL numbers do not have to match, by the way. Those are locally significant only. Router 2 has no idea what ACL has been written on router 3 and vice versa. Just did it for consistency, foolish or otherwise. So now we've got our ACLs written. We have our interesting traffic defined. And now we're going to finally get to the meat of the matter, and we're going to write a crypto map. And let me show you the syntax for that. We're going to call this one CCIE, so we're not using the same acronyms for everything, because gosh, we've written a couple different things here, one called CCNA and then one called CCNP, and here's our crypto map called CCIE. To me, when you start naming everything the same thing in a lab, it gets a little bit confusing, so we're going to call our crypto map CCIE, and we're not quite done yet. We do go ahead and give it a sequence number here, and I'm just going to get 100. And IPsec ISACemp is what we want. IPsec with ISACemp, that is. And we're going to leave those options for another day, and we are done. And then, you know, you always hold your breath. The first time you do something, especially, you write something that's like, oh, here's a note. Oh, here's a warning. Well, let's take a look at this note. This new crypto map will remain disabled until a peer and a valid access list have been configured. And you look at this and you think, well, we have a peer and we have a valid access list. What they really mean is this crypto map will remain disabled until you've defined a peer and a valid access list in the crypto map. So basically, you can ignore this. It's just reminding you of it. So what we're going to do here is set a couple of values for traffic that matches, oh, I don't know, the ACL 103 we just wrote. So let's look at our match options here. What we're doing is matching on something, and so far it's match address. Notice it says of packets to encrypt. And then it gives you your two ACL ranges that are acceptable, and I think we both know what those are. Those are extended ACL ranges. And you could have also used a named ACL if you wanted to, but it was still going to have to be extended. You can't sneak around that rule by using a named ACL. So we had 103, which is what we're going to go with, and that's it. So we want traffic that matches address 103, which is our ACL 103, to have certain characteristics. We're going to set a peer for it, and we're going to set the transform set for it. We called the transform sets CCNP. So let's have a look at our set options. And as you see, we got quite a few things here we can set, but the one we're really interested in first is peer, and that's allowed encryption decryption peer. It's exactly who we wanted. And then we need to name the transform set. Notice the transform set option says specify list of transform sets in priority order, because you were probably wondering, how can you give priority to one transform set over another? Because transform sets don't have priority numbers. We went over the rules for ISACemp. We saw the numbers. We saw the priorities given the default policies. We saw, we assigned the priority 1 to the one policy that we wrote. But we never had that option with transform sets. Now, we did just have a sequence number here, but that's not the same thing. So what you can do is, if you have multiple transform sets, which we do, and you want to send them all over or send more than one over, put your preferred one first with transform set. I'll show you what I mean right now, actually, because we are going to set two things. Now, proposal tag, the first one I wrote, the one we wrote is CCNP. That's the only one I'm going to send over, but notice that it is saying, hey, do you want another one? Or you could just hit create here and commit carriage return, I should say, and that's it. So actually that is it. And we're also going to set a peer of 10112. And that's all there is to it. So there's absolutely nothing wrong with having multiple set statements in there for one match. You probably will, actually. You'll definitely do that for a site-to-site VPN. If we show a crypto map, do a show crypto map right here, what do we get at this point? Now, you'll notice it says at the top there, crypto map CCIE 100 IPsec ISACemp. The peer is 10112. There's your extended ACL. It even shows you the contents of the ACL. So this is a great verification command and a great troubleshooting command on top of that. And we're going to leave a couple of the options alone here. It does mention to you the one transform set that we put in, and it even has the characteristics of that particular transform set. So this command, show crypto map, it's not only going to show you what ACL is in use, but it's going to show you the contents of that ACL. It's going to show you what transform set you have in and what we defined for those. And notice that under interfaces using crypto map CCIE, it says absolutely nothing, because we haven't applied it yet. And that's, it's like when you learned ACLs for the first time. You got to remember to apply it. You're so excited you got it written. It's like, yes, but now you got to apply it. Well, we still have to apply our crypto maps. We're going to do that after we go over to router 2. We could have done it there, but we'll do it here anyway. CCIE, we'll call it the same thing. And you get the exact same message. And we're going to match IP address 103. Oh, what did I do? You'll do this too. It's really hard not to put IP in there. Match address 103. Well, what do we think most of the time, especially when we're routing? You think IP address. So what do we want to do? Set a peer of 10113 and set our transform set. Nice try. To CCNP. And we are just about done. We'll do a quick show crypto map. See the same information as you saw from the other side. But if you're starting to do a little troubleshooting, always check this command first and make sure that you have something under interfaces using crypto map CCIE. Otherwise, there's no way in the world it's going to work. Now, let's go ahead and have a look at how we are going to apply these. And we're going to apply it straight to the interface. And we're going to set a crypto map. And what's the tag for it? The crypto map tag is CCIE. We're going to leave redundancy alone, and note again, there's no in or out here. When we put a crypto map or apply a crypto ACL to an interface via crypto map, it's working with inbound and outbound traffic. So that's all there is to that. And we got a little extra message here beyond the system message. Crypto ISOCMP on off. ISOCMP is on. Well, I kind of like the sound of that. That sounds positive. Let's go ahead and run show crypto map. Pardon me. And you'll see at the bottom there, interfaces using crypto map now list fast Ethernet 00. Let's head over to router 3 and do the exact same thing on fast Ethernet 00. Crypto map, then you just put the name of it. And we're going to leave that alone. And we will run a show crypto map after again getting the ISOCMP is on. And we can see at the bottom of this list, there's again the transform set, CCNP, the ACL, the usual info. But now we have fast Ethernet 00 at the bottom. So, I think it's about that time. It is about the time we test this thing. We've got everything written. We've got everything in place. And even if this works right the first time, I'm still going to come up with some troubleshooting scenarios for us to look at, because it's important for you to know how things look when things are working, and also, of course, when they're not working. So we'll hit all of those scenarios in the next couple of videos. See you there.